Alright, here we are. Problem 624 from statics. So much fun. So basically what we have is maximal allowable tensor force and compression force. So first we have to do, we actually have to solve all the forces in each one of these members. And then we put in all terms of P. So the first thing we gotta do is actually solve for the supportive forces. EY and EX and then AX. Alright. And the first thing we do some moments about E. Let me set that equal to 0. We're gonna go ahead and say this way is positive. So that would give me, and this is, now with D is equal to 2 meters. So that's 2 there, that's 1, that's 1, that's 2, that's 2. So, because of this, we're gonna get 2p minus 3 a to the x. So, we get a to the x is going to equal 2/3 p. And then we do some forces in the x, and that's just going to be the e to the x. Negative e to the x plus e to the x, right? That equals 0. So that means e to the x is also going to be 2. God, I'm terrible at writing out this thing sometimes. 2/3p. Alright? Super simple. Super simple. And some forces in the y equals 0. This way positive gets me e to the y minus p, which just means e to the y is equal to p. So I'm going to start at point A and then work my way here from A to B, then to D, and then finally to C. Really, that's all you need. You don't have to go on to E. You only have to do 4 points, which because that's going to give me that, and so on. So I'm going to start at A. And A, we have a to the x going that way, and we always assume these are going to be in tension, right? So FAD, so FAB, and now, so all you have to do to find the angle is do inverse tangent of 1/2. So it's going to give you 26.56. That's going to be Sainsbury, and we're just going to go ahead and call that 26.56 alpha, because I don't want to write it out too much. So we're going to get sum of forces in the x. It's going to equal, I want to make this way positive, a to the x plus f ad cosine alpha plus f ab cosine alpha. This is all equal to 0. Nah. Well, as you can see, we're going to have a little bit of problem solving for that. So we're going to do some forces in the y, which gives us f ad cosine alpha plus f ab cosine alpha. Right, all equals out. And honestly, these are going to get, actually, I messed up there. It's actually f ad minus f ab. These are going to cancel out. So you'll be left with f ad to f AB. And so you can just take that, plug it into this. Remember, this is 2 over 3 P. And everything's going to be in terms of P. And once you do that, you can find out FAB is going to be equal to negative 0.373 P. And since FAD and FAB are the same thing, I'm just going to go ahead and just write this. That means this is going to be a compressive. So like the maximum allowed for these two forces, it's going to be that 3 kilonewtons. Alright, and now we're just going to go to B. Right? Just going to keep going down till we make it. Oh god. What the hell am I drawing? So then, it's B. That's F, A, B. Alright. This is going to be F, B, C. And this is F, B. Yeah. No, it's not F, B, C, it's F, B, D. My bad. Alright. We know this one. We know it's 0.373 P. And I drew it in compression. So that negative comes out because I drew it as such. And this CX. And this degree is actually also alpha. If you look back in the drawing, this angle is going to be the same here. So that's alternate interior angles. You get the same angle here. And remember, alpha is equal to that nice 25.56. So first things first, do some forces of the x equals 0, which is going to give me an answer right away for FBC, right? Because it's going to be this way positive, right? And we're going to get F AB cosine alpha plus F, oh, oops, yeah, no, BC cosine alpha, right? So again, these would cross out, and essentially FBC cannot equal that same. But really, that just means it's in compression, right? And now we do F forces in the Y. That's way positive. When we get it, that means FBD. It's just going to be minus. I'm just going to go ahead and write that as this. No, P. Almost forgot the P. My bad. Cosine. No. That's very wrong. Sine alpha. Right. And FBD comes out to be 0.334 P. And this right here is tension. Okay, doing good so far. 2 down, 2 more to go, right? And we're going to move on to point D, which has F, DB, right? It has F, AD, it has F, DC, and then F, DE. Okay. So, and as you know, these angles are going to be also equal to alpha. I'm just too lazy to write things out. So you got some forces in the Y, and we're going to do some forces in the X, equals 0, which give me F, AD, and as you remember, this is also equal to that 0.373p cosine alpha plus f dc, because I wrote in tension cosine alpha. Alright, and like I said, crosses out, then you're left with FDC equaling another negative 0.373p, which means compression, yay. And then you do some forces, the y equals 0, which equals F. This way pops in FDE minus FBD, which is right there, right? Plus the same thing as last time, 2 times that 0.373 sine alpha. This looks very similar to this, right? Yeah, because this gave me that. So this and this actually cancel out. And you're left with FDE actually equals 0. Right? So boom. We're done with 3 points. Down to the last point, point C. Super easy now, because I have actually solved for 2 of the forces that are going to it. It's really let me use black. Oh, I'll do that. We got point C. Right? So really what we'll be left with is that FDC here, that FBC, and then we'll have this one that comes out this way, and that's FCE, right? And we have this, got our coordinate plane, this, it's going to be the alpha. Now we need to find this angle, right? Which is a bar. And basically that angle is going to be this triangle here, which is 3 to 2. So you do the inverse tangent, 2 over 3. Nope, I don't want to do anything like that. Which gives you actually 33.69. And now, actually, all you have to do is do some forces in the y, some forces in the x. I'm going to do some forces in the x because I find that easier because these both going different, not actually going the other way. So make that positive, that equals 0. Which basically means I'm going to have 2 times 0.373 times cosine alpha minus FCE sine that 33.69. Right? Because of the way I drew my angle. And when you solve for this, you're going to get FCE equal 1.203p. So basically, if you look at all your solves, you really only have 2 different ones, and this one's in tension, right? So you really have 2 different, 3 different values. So what you do, so you have 0.373p, right? And this is in compression. This one's going to go 3 kilonewtons. And I have 1.203p, which is in tension. So that's going to be 5. And I have 0.334p. It's also in tension. So that's also going to be equal to 5. And so thus, this one's gonna have a P here. You're gonna solve for each P. And whatever's lowest is the one that's your answer. When you solve for P, it's gonna be 8.04. Then when you solve for P, it's gonna be 4.16. And when you solve for here, it's gonna be 14.97. And this is all in kilograms. Just gonna write it down. And so, like I said, the lowest P is your answer. And so in this case, it's at 4.16 is what it's going to be. And that's it.